Welcome to Halteres Presents, a brand agnostic interview podcast that seeks to objectively highlight the happenings within the world of diagnostics. And now, your hosts, Thayer and Mickey Urdea.
Hello, and welcome to this episode of Halteres Presents. My name is Rich Thayer, managing partner at Halteres.
And this is Mickey Urdea, founding partner of Halteres Associates.
We're going to have two parts to this interview with Paul Davis. In part one, will be a retrospective of his career since the 1960s and the founding of the consumer diagnostics industry. Paul was one of the inventors of the first home pregnancy test when he worked at Unilever. Who would have thought that Unilever would have had such a large part in the founding of this industry?
We're very happy to have the chance to give Paul an opportunity to reflect on his career. He's been an innovator in this whole area of consumer diagnostics for decades, and he'll actually help put in perspective the things that occurred over that period of time that led to where we are today. And he's still an innovator today.
And now, part one of our interview with Paul Davis. Hello, Paul, and welcome to this episode of Halteres Presents.
Thanks so much for joining us, and we're eager to talk with you. As a start, please let our listeners know a little about your background. It's very interesting, and we're eager for you to share it.
Thank you. It's a privilege to be here. It's very timely as I'm preparing for retirement, and it's been very interesting to make myself look back over my career and see where there might be useful learnings for other people. So I'm privileged to be here, and thank you very much for including me.
Thank you.
I want to start off by saying that I must be one of the most fortunate people in the world, certainly one of the most fortunate people to reach retirement age of 76, having met so many wonderful people, having worked with so many wonderful people, been in teams which achieve because of the structure of the team, because of the respect and transparency and energy brought by those people in the teams. It made me very reflective about how innovation needs to work in order to make it successful. So all of these things come together at this stage. But just to give you a feeling for what I worked out that a short while ago was actually 58 years of working in life sciences. So I started at 18 in 1965, and I was a junior lab assistant in the Unilever research laboratories. They don't come at a more junior level. And I was there because of my love of laboratory science. Fantastic. Really enjoyed gas liquid chromatography, linking up with mass spectrometry as a very young person with not many qualifications at that point. Analyzing foods, pesticides in foods, lipids, sugars, polysaccharides. I loved it. That was beautiful. And I didn't have any long-term plans for a career at all. And so I just carried on doing what I enjoyed and studying part-time. And all of my qualifications have been gained by part-time study through pre-university qualifications, and then London University as a part-time student doing an honours degree, and then doing a PhD part-time, still all while working in Unilever research, and subsequently with honorary professorial appointments much later in my career. That's been enjoyable. It worked for me. It wouldn't necessarily be right for anybody else, but that's how it worked out. In the 1970s, though, moving up to scientist level from junior laboratory technician, and also doing a part-time degree followed by a master. So I'm going to take this decade by decade. Otherwise, we'll spend far too long delving into this particular history. I was able to transfer in 1973 to the Philip Porter laboratories in Unilever research at Colworth, where we were doing fundamental work on the mucosal immune system, especially in relation to pigs and farm animals. And my word, I enjoyed that even more. It was fantastic. It was able to take me into my love of parasitology, which led me to have a lifetime's fascination with immunology, so that I now call myself an immunologist with a particular interest in parasitology. I was an early adopter of ELISA technology, which came out during the 1970s, and also using liposomes as markers, which are still coming up today. That was a greatly exciting thing to do, and that led me eventually to write reviews on what liposomes might do. In the end, they didn't make the grade, but it was fascinating and enjoyable. That decade, the 1970s, ended up with me in a position to be able to make a promise to Unilever management that it would be possible to take our immunology into the field of consumer diagnostics in the form of pregnancy tests. And I was able to make them believe that when you look at pregnancy tests of the time, which were incredibly crude and difficult to use, agglutination, where you had to leave it static for ages and then minutely look at whether you've got a button or a cloud of material in the bottom. They sold, but not in very great numbers. And the promise was that we would be able to make a Unilever-specific technology that would allow them to take on the consumer market for pregnancy testing. That was a bold promise and was actually quite difficult to fulfill. In a very small way, it's a bit perhaps like Kennedy saying we're going to take a man to the moon and bring him safely back. And he didn't quite know how it was going to be done, and I didn't. And I was luckily working with colleagues who had the ability to take ideas and develop them. And it was through that team that we were able to come up in the 1980s with the pregnancy test known as Clearblue. During the 1980s, I did my part-time PhD with the University of London. And if anybody's interested in how a company like Unilever could take on a pregnancy test development resulting in the lateral flow technology, there is available, I think Harvard are offering it. It's a Taylor and Francis study by Jeffrey Jones and Alison Kraft. Jeffrey Jones was at Harvard Business School, entitled Corporate Venturing, the Origins of Unilever's Pregnancy Test. And it might be worth reading because it tells you a lot about how a big company, massive company, managed to create a small working group that was kind of insulated from the corporate structures and could act as if it was a sort of entrepreneurial group and almost like a small company within a company. And it was that enabled this flow of creativity that came from the team. And so in the 1980s, we had a flirtation with consumer diagnostics. And the very first pregnancy test wasn't lateral flow. It was a dipstick with a stick that was about the size of a biro pen that sat into a little matchbox-sized workstation. And it was an ELISA. And people had to do 3 steps. And it worked. And it sold well. That was launched in 1984. And the market went up and up, and consumers loved it. But it didn't make a huge impact because it was an early marketing product. But it showed Unilever how a neat test could really become an attractive consumer product. But the wisdom then of Bill Hornby, who was running Unipath at the time, which was the small company within a company, said, this is going to be superseded with simpler tests, and we're going to be the people that will supersede it. And so he set up the rat run, which was to take the most enthusiastic scientists within that group, shut us away for a day at a time, fill the walls with pinned up whiteboard or flip chart things. And then at the end of each session, we were paired up. I think there was 10 of us paired up to go away and do experiments on the ideas that had been thrashed out. And through that process, the lateral flow was thrashed out over many meetings and many wasted flip charts. And it was very exciting. It's called the rat run because RAT stands for rapid assay technique, and run was the run that we were doing with it. Fabulous experience, and it was so wonderful. And now is the time for me to say that the 2 key people that really picked up the emerging lateral flow thing were Keith May and Mick Pryor. And so I need to make it clear that it was very much a team effort, and it shouldn't be just seen that it was me that did it. It was us. And that really stands as a wonderful example of how technology can come from the most unlikely source. Who would have thought that Unilever, famous for its ice cream, famous for its food, famous for its cosmetics, in other words, a very sophisticated multinational grocer, could come up with lateral flow? A great study.
Paul, one little thing. When I first started out in diagnostics, it was because I worked at a free clinic in Southern California. And it was 1971. And I'll never forget doing the agglutination pregnancy tests and having all those young women sitting there waiting for the results. And it was just amazing. I remember it well.
Okay. Fantastic. We've got very similar origins.
Yes.
Okay. During the 1980s, we also started looking at fertility testing as well, and really getting to grips with ideas such as Imagineering. And Imagineering was actually, although it's taken over by the Disney Corporation, let's just leave Imagineering for the moment. So I think we should move on to the 1990s. And in the 1980s, I'd done less lab work. I'd been more doing research leadership, but still doing hands-on research. But in the 1990s, it was moving away from the white coat and my love of the laboratory bench. In fact, because I was working with people who were so much better at doing that than I was. And so I was able to be somebody who thought about things and was involved in research leadership. The 1990s for me were really all about antibody engineering. And this was really driven by Philip Porter, who was my boss at the time, who must take enormous credit for actually working at the top level within Unilever to secure this innovation group called Immunology and Unipath. And so Philip Porter was a real mentor for me and for so many other people. So he was able to lead us into this emerging idea that monoclonal antibodies, which had started in 1975, was going to go further, and we're going to start having engineered antibody fragments that could be expressed in microbes and yeast, and that could be used in Unilever in all sorts of different ways. And initially, the antibody fragments were going to be used in toothpaste to fight caries forming bacteria forming in the plaque on toothpaste. And this idea had been developed by a person in Guy's Hospital, and he'd shown the way, and Unilever wanted to follow by having antibodies in toothpaste. Great idea, but it focused us on the challenge of how do you go from a monoclonal into active fragments like single chain FVs, single chain, and also even smaller. And that led us to start working with our Dutch colleagues on camelid antibodies and seeing what they could do. So in that time, working with Paul van der Locht and Martin Verhooyen, I was able to play a part in this adventure of moving into engineered antibodies. And again, what a surprise that the multinational grocer Unilever was leading the way with antibody engineering. And with this wonderful team that we built up, we were able to make the first double variable domain bispecific single chain FVs. We patented it. And since that, in the early 2000s, I was involved in patent disputes around who had first come up with these types of bispecifics. And guess what? It was actually for certain types of structures, not for all of them. It was the Unilever patents, but they'd been abandoned by Unilever at that time because I'd left to do something different. Paul van der Locht had, Martin had, all the key players had moved on to something else, and Unilever didn't realize how valuable these patents were. And so they were being taken up free of charge by people in the pharmaceutical sector. But the other thing that went on in there was the Persona fertility self-test with algorithms that allowed people to identify, for ladies to identify when they were in the fertile time of the month. And that was, again, a very interesting way, but it was a very difficult thing to be done, because by reading the luteinizing hormone profile each month on an almost daily basis and the estrogen and the progesterone, it was possible to identify the start and the end of the fertile period, but everybody varied. And in trials, it was found that this was 95% successful as a way of being a contraceptive approach. But of course, it depends very much on people being very firm about the way they organize their lives. But if you've got 95%, which is good, which is almost as good as the condom process, one of the challenges is that when used in a contraception mode, for every 1,000 tests you sell, you can expect there to be 50 unwanted pregnancies. And that would create some very bitter people who didn't want it. Now, that's fine if you're not sending it as an impulse buy, but you're selling it to a niche, but quite a large niche of people who want to space their family. And in which case, an unwanted pregnancy isn't that bad, but they have the benefit that they're getting that 95% control of timing pregnancies. So it's still on sale, but they sell it in the other way, which is that it's for people knowing how to improve their fertility by understanding the way the cycle is working. And it's a brilliant product. It really is very effective. And I'm really proud to have been associated with it. So as we moved on with the different antibody technologies, we realized that there were some really exciting developments going through, and we looked at other ways to use them. We even set up an oncology application group for it. But again, that was pushing things too far within the Unilever context. And it was ending up being of more interest in the toothpaste or in targeting bleaching enzymes in laundry systems. But I was able to take on a different kind of role where the company asked me if I would take on a role as the Unilever Research creativity mentor. It was an attempt to try and increase the creativity aspects of the company. The company was focusing on delivery, on brands, and it was felt that in order to keep the research part of the company really driving forward in a creative way, they wanted to take every action they could to stimulate creativity. We all quickly realized you can't teach creativity, but you can get people to understand their own creativity, get team leaders to understand how to enhance the creative delivery by making it a creative environment. Lots of things that taught me lots of lessons, and hopefully some of those lessons filtered through to the people that I worked. And we set up the Falling Apple Centre for Creativity Mentoring, and it reached out into European laboratories and North American laboratories. So moving quickly onwards then, the 2000s saw me leave Unilever, having actually, it was a formal retirement, to become an entrepreneur. And this was enabling me to put into practice the things that I'd learned and passed on about mentoring creativity. And in the 2000s and 2010s, I was able to start 6 life sciences companies, 4 of which are still trading. One of them is called Aracle Therapeutics, that was spun out of Incense, which was a wound care company, and that is now listed in the UK stock market, in the AIM stock market, and doing very well. That was because of the brilliance of Jan Yazak, a Czech scientist who made it home over here, and they're stabilizing products with incredible efficiency and working with big pharma. And there's the Onyx Myco fungal nail remedy, which has come out of the Incense wound care product. Then in 2003, my son and I set up Mologic. There'll be more of that later. That had an interesting history. In 2009, it was bought by Alere. Alere was subsequently bought by Abbott. But in 2014, we bought Mologic back and set it up as an individual, a separate, independent family company. And it carried on and has grown and changed out of all recognition from what it was in 2015 when we started to rebuild it in a different way. And that was a very fast run through a very interesting and very up and down time. It was something that I wished I'd perhaps done earlier, but it was really interesting to set up companies. I mentioned that 4 of them were still working, so global access. But in the 2010s, I was privileged to set up a company with my daughter called Austin Davis Biologics. So how's that for privilege? I think I've been so fortunate to be able to set up companies with people who I greatly respect, both on the investor side and on the team working side. But on top of that, I've had the fantastic privilege of being able to set up a company with my son, and then in 2010 with my daughter. Like me, she's interested in parasites and in immunology, but also interested in horses. So her company, Austin Davis Biologics, is focused on diagnostics for horses. So I mentioned that in 2015 we bought Mologic back, and the Austin Davis Biologics company was flourishing and still is doing. And within Mologic, we had taken on some exciting innovations developed during the time that we were in ELEA, and we call these our kind of heritage products, and we'll talk more about that later on. The COPD test for predicting exacerbations, called Head Start, the Periplex test for detecting infections in peritoneal dialysis, Utriplex test for UTI infections. And of course, in 2018, there was the Diagnostics setup, which Mologic took a leading part in through Mark's vision and determination to do something even more powerful for LMICs. There's a story there. And of course, we had the CARD, the Centre for Advanced Rapid Diagnostics, which set up in 2017. And again, what a fantastic privilege for me, having been there and involved with the original invention of lateral flow, to be said, we want you to now go back and look at lateral flow in a completely different way and see where it can be improved, where it can't be improved, what can we expect from it, what are the underlying scientific issues that make it have whatever limitations it has. And I could barely believe, and still can barely believe, what a wonderful opportunity that is. And I'm so pleased I had that. Then the 2020s, obviously the COVID pandemic came along and blew away all our plans, because everything was then subverted into the COVID response. Well, not quite everything, because we managed to keep other things going. Things like our electronic lateral flow test technology, the vision for making other derivatives of lateral flow, and where might it go when you begin to really understand all the science behind it. And that's our Adelphia, the nucleic acid testing, and other things that I'd like to tell you about later on. So there is 58 years in a nutshell. What a fantastic and enjoyable time it's been. It's had its ups and downs, but my goodness, it's been better than I could ever have imagined.
What an inspiring career. Thank you for that.
Yeah, thank you so much for that fascinating history. We'd like to get into some of the other aspects of it as well. So, for instance, what were some of the challenges to design tests for an untrained user to perform properly?
It was all about how to try and make an ELISA test, because initially when we had the brief to go into this in 1982, 83, we didn't have lateral flow. Nobody had lateral flow. And the idea was to try and make a dipstick work as an ELISA. And we came up with this model of a dipstick that had as its nib a little, what we called a PEG end, which was a serrated end that was able to sit into the sample. And there was what we called a shroud, and with this dipstick, with a handle on one end and a shroud at the other, where there was I should say a splined tip to it, it meant that when a woman introduced the end of this into a flow of urine, it automatically captured a few microliters of urine. And this was then transferred into a tiny workstation about the size of a matchbox. And she had to leave it for 10 minutes. And then there was another well in this little workstation. You peel back the top, and in there was a conjugate solution already dosed in. So she take out the peg, rinse it under a tap, put it in well 2, 10 minutes, well 3, 10 minutes, which was the substrate, which caused a blue precipitate to form on the end of the stick. And that we had to then take that to focus groups and say, could this work? Focus groups were young women of childbearing age. We took lots of focus groups. And Steph Senior, who had been one of the team that was developing the technology, took on the marketing and worked with Unilever's formidable marketing capability. It was a big advantage. And we were able to work out how this could be presented, how it could be used, how it could be described. And we found that women loved the idea, at least those that we tested it on, of doing something simple but that seemed scientific to make them earn the result. When they got the blue thing out at the end, where the tip had turned blue, and they knew they were pregnant, then that was an achievement which made it even better for them. And so that was put on the market and advertised using all these insights. And so a fairly clunky test was actually very attractive. But I think, Mickey, you would agree that would be far better than the very early tests that you had experience of.
Oh, yes, much. Yeah.
And it went down well. It was called Clearblue because the end went blue, clearly, if she was pregnant. But it was recognized that this would only be temporary because competition will come in and would undoubtedly make something similar. So the challenge was out. We're going to be the people to knock that out of the market. And that was where we ended up with our rat run. But all of that, as soon as we had the concept, straight back into the focus groups. So it was like 2 steps, stepping forward. First step, get a technology that looks like it will work. Second step, take it to the market, check it out, see if it's good enough. What can you do to improve it? And that meant that we ended up having to have a protruding absorbent wick so that it could just be put into the urine flow, and that would immediately take in the sample. Put the cap on, clean, hygienic, those sorts of things meant a lot to the women that would use it. And the result was that in 1986, 87, the lateral flow test was born, and it was going on the market. And its first exposure was in the New Scientist magazine, and I still have a copy of that one. And so the concerns were that we might be introducing something that would be unacceptable and it would be too difficult for people to use reliably, because sometimes you can have something that is intrinsically accurate but can't be used simply enough. But we managed to avoid that, and that was how it came. The concern was, would it work? The other bit was, will doctors ever recognize it? Will they insist that they won't understand, that the GP won't believe the result, and therefore the user will feel that she's got to have a more conventional result as well. And for Unilever directors, this was steps in the dark for them. So I think it was Keith May or Bill Hornby went to the Unilever International Board of Directors to show them it working. And he said, I'll show you a negative test. There was a flagon of water in the middle of the table. And he dipped it into the flagon of water and it came up positive, which was a huge worry at the time. But in fact, it was simply because it was optimized for urine, not for water. And there was non-specific binding. It was a bit of a crisis. So that was a concern. Would it really be reliable? Was Unilever daft to manufacture and sell something like that?
Were there any surprises from these focus groups about what the problems were with the test in their hands?
Well, yes, I suppose there was, that women were keen to do something to get their result. They were happy to engage with this process. And whilst it was very clear that the new one-step process was much better. We were surprised that for the following few years, both tests were sold as the original Clearblue or Clearblue one-step. And I actually had to kill the original Clearblue because its sales carried on. They weren't taken over by the one-step. And that was proving, I think, that there was a subset of users, which we'd already sort of reached, I think, that liked the fiddly bits because they weren't too fiddly, they were quite easy. And they liked to have felt they earned the result. And that surprised us. But we stopped it because it didn't make sense to have two Clearblue tests. And the world then adopted lateral flow. We had no idea that it would achieve what it has achieved. We thought it was just an OTC, over-the-counter product.
Let me take a little side story here because you remind me of it. There was a very famous marketer named Edward Bernays, who actually was a cousin of Sigmund Freud. And he was testing the product Bisquick, which was early in the 1900s, where a woman could add water to it, make biscuits or make pancakes or whatever. And they didn't like it. And the reason they didn't like it is they felt that they were cheating their families because they weren't actually cooking. So he came up with the idea, you have to add an egg to the Bisquick in order to make the biscuits. They liked that. And from that point forward, it was a very successful product. So
isn't that interesting? It's about giving people something they can engage with.
Exactly.
Amazing. Paul, thank you for that engaging history of Clearblue. Thinking back on the launch of Clearblue and the input from the focus groups that you received over time and after it was on the marketplace, how have opinions changed about the use of lateral flow technologies or rapid testing technologies?
Oh, yes, that's a very good question. And they changed far more than we thought they would. It's got to the point now where I don't think any woman goes to the GP to ask if she's pregnant. The whole thing has switched. It is now the norm to actually do your own home pregnancy test. And that's really quite exciting in other ways because there's a lot of talk correctly about making lateral flow tests or other kinds of rapid tests available for health issues. And of course, pregnancy is not a disease. It's a health concern that needs to be properly managed so that mother and baby do well. But because that has been so widely accepted, it is the absolute international norm to do your own pregnancy test. And GPs accept it. So there's no GPs shooting from the side saying you shouldn't be doing this, that's our job. And so there must be many other ways in which lateral flows can affect actual diseases, infectious diseases, and so on, which we'll touch on later, I suspect. And that has changed enormously.
We hope you have enjoyed part 1 of our interview with Paul Davis. And don't forget to come back for part 2.
Thanks very much for listening.
Halteres Presents is produced by Halteres Associates, a US-based bioscience consultancy that provides strategic and tactical services in the areas of diagnostics, medical devices, and life science research to clients of all sizes. The views, information, or opinions expressed during the episode are solely those of the individuals involved, and Halteres Associates is not responsible for any errors or omissions or for the results obtained from the use of this information. The information provided in this episode is for informational or educational purposes only and is not intended or implied to be a substitute for professional medical advice, diagnosis, or treatment. Halteres Associates would like to say thank you to this episode's guest or guests, and thank you for listening to this episode of Halteres Presents.